In this video, we will explore the relationship between segments and circles. Now, the formula that we will use depends on whether or not the segments intersect inside the circle, in which case part times part equals part times part, or whether the segments intersect outside the circle. And in that case, the outside times the whole equals the outside times the whole. And this is a special case. All right, so we're dealing with segments. So the segment formulas are like these. But when we're inside the circle, like we are here, we're doing the first one. So we're doing part times part equals part times part. Okay, so what is the first part times part that you're going to do? Like x times 4. All right, if you're looking at this segment right here, the parts are x and 4. So x times 4, or you could just say 4x equals, and then what's the other part? Right, okay, because it's like the 6 times 8. All right, so 4 times x is equal to 6 times 8. So that means 4x is equal to 48. And then, of course, you divide both sides by 4. So x is 12. We were supposed to circle the formula that we used, so we'll just circle that we did this one. So for this one, we see that the segments are intersecting outside the circle. So that means we're going to be using these formulas over here. Now, really, these two formulas are the same. Okay? They both really mean the outside part times the whole is equal to the outside part times the whole. It's just that in this special case, when you have a tangent segment, which is what x is, then the tangent segment is the outside part and the whole. So really, sometimes it's more convenient to think of it as a new formula. So if you had to circle just one of these, then this is the one to circle, because this one is especially for this special case where you have a tangent segment, and this shows that the tangent segment is the outside and the whole. But if you use the middle one, it's really the same thing. Anyway, so let's go ahead and set it up. We're definitely not doing that one. So the outside part times the whole. Let's start off with the 12. The 12 is definitely the outside part. Now, the whole is going to be the 27 that they nicely marked for us. So it'll be 12 times 27, because that's the outside part times the whole. Now, that leaves the tangent segment. And remember, the tangent segment is the outside and the whole. So we're going to wind up doing the x twice. All right, tangent times tangent, x times x. So of course we know that x times x is x squared. So that's what you're going to get. Now 12 times 27, I am not sure. 324. So I have 324. If I want to solve this, I need to take the square root of both sides. And that is 18. All right, so let's start with which formula applies to this situation. Correct, right? When you're outside the circle and we're talking about segments, it's the one that goes part times whole equals part times whole. All right, so give me the first part in whole. In fact, I should say outside. Instead of just saying part, I'm going to say outside.
Oh, I see what we're doing wrong now. Instead of 39, it's supposed to be 49.
All right, let's just keep going. So, what's give me the first outside and whole.
14 times x plus 14.
14 times x plus 14. Okay, and how about the other part?
10 times 10 plus 13.
All right,
Okay.
10 times 49. So, right, doing the distributive property right here will give us 14x plus 196 is equal to 490. Then if we subtract 196 from both sides, so we will have 14x equals, what's that? 294. And then we divide both sides by 14. And what's that?
21.
So x equals 21. All right, what is going on with this one? So the angle is outside the circle. So this is going to be the formula where we do outside times the whole is equal to the outside times the whole. Now this is a special case where we have a tangent segment here, and so there's only the one part. So another way to think of this, instead of saying outside times whole, this tangent segment is going to be both the outside will be the tangent segment, and the tangent segment is the whole also. So another way to think of this is tangent segment times tangent segment. All right, but it's really the same thing. So let's start with this part up here. You can probably see that the 6 is the outside part. So I will have 6. Now be careful when it comes to the whole thing. Some students accidentally just put x. That's wrong because x is only this part. All right, that's not the whole thing. Some students accidentally put 6x, but that's not right. When you want the total, you are adding. So the whole thing is 6 plus x, or x plus 6. And then comes the tangent segment. So again, the 12 is the outside part and the whole. So let's do the distributive property. So that will give us 6x plus 36 is equal to 144. Now let's subtract 36 from both sides. So that's going to be 108. So I'll have 6x is equal to 108. And then I need to divide both sides by 6. And that is 18. All right, that's it for that one. All right, below, segment BC appears to be tangent to circle A, but the lengths tell us that it is not really tangent. Use calculations to show how we know that it's not. So the way we're going to show is by using the Pythagorean Theorem. If this is tangent, then it should form a right angle. That means that this should be a right triangle. So we ask ourselves the question, it's basically going to be, does a squared plus b squared equal c squared? question mark. And if the answer is no, then that proves that this is not a tangent. Okay? So we'll say, does 20 squared plus 50 squared equal... Okay, so I have to be careful. If I said 32 squared, that would be wrong. Can you tell why 32 is not the right number to use? Okay, the reason why is because 32 is only that part right there. Okay, I'm switching colors for a second. Get it? How big is this purple part? That's 20. I can tell because of the other radius is also 20. So this will be 20. So the hypotenuse, instead of being 32, what really is it? It's really 52. So I have to ask myself, does 20 squared plus 50 squared equal 52 squared? Okay. Does 400 plus 2,500 equal 52 squared? Right, 2,704. Okay. And so this is going to be 2,900. And 2,100 does not equal 2,704. So I'm going to say no. 2,900 does not equal 2,704. So segment BC is not tangent. In this problem, we are given that segment BC is tangent to circle A. So when you have a tangent segment like this one, it is automatically going to be perpendicular to the radius. So we know that this is a right angle, which really means that this entire triangle is a right triangle. But before I go all the way there, I need to know what this little part right here is. Can you see that this purple piece is going to be 24 because it is a radius, and we already have a radius of 24. So every radius will be 24. So to find x, I'm going to do a Pythagorean theorem. However, please understand that the hypotenuse here is going to be the sum of these two. So that's going to be 40. So when I do the Pythagorean theorem, I'm going to be dealing with a hypotenuse of 40. So a squared plus b squared equals c squared becomes x squared plus 24 squared equals 40 squared. Right? We have to be careful to put the hypotenuse over here by itself when we do the Pythagorean theorem. So that's going to give us x squared plus 576 is equal to 1,600. So time to subtract 576 from both sides. So that's going to give us x squared is equal to 1,024. So of course, to get the final answer, we need to take the square root of both sides. So that is 32. All right. So in this problem, circle the two lengths that must be equal. Catherine, which two lengths did you suppose were going to be equal? Correct. All right. These, when you have a tangent, when you have two tangent segments coming from the same point, they are equal. So correct. The 3x minus 4 and the x plus 8 are going to be equal. So then that means 3x minus 4 is going to equal x plus 8. Is that what you did so far? All right, what did you do next? All right, that sounds good. So did you get 2x minus 4 is equal to 8? Okay, so that's where you went wrong. But I'll keep good. Do you understand why I'm getting 2x minus 4 equals 8? Oh, that's what I'm going to do next. Okay, so we had 2x minus 4. So when you subtracted x from both sides, 3x minus x is 2x. Okay, so I just brought everything else down. So now I have 2x minus 4 equals 8. So you should have that on your paper somewhere. Then the next step is to add 4 to both sides. So that's going to give us 2x equals 12. And then when you divide both sides by 2, you get x is equal to 6. Does that make sense? You had that. Okay. So now that we have x equals 6, now we can substitute that into different things to find whatever they're asking us for. So BD, we have this expression 3x minus 4. All right, this is for BD. So if x is 6, then that makes it 3 times 6 minus 4. So that's 18 minus 4. So that's 14. So we have 14 for BD. Now I could put in 6 for x, or I could just notice that these are the same. So I know, oh, well, they don't ask me for DC, do they? Never mind. So they asked me for BA. So for BA, the expression is the 7x plus 6. So that's going to be 7 times 6 plus 6. So that'll be 42 plus 6. So that'll be 48. Does that make sense? So BA is 48. And then that just leaves AD. For AD, we're going to have to use the Pythagorean Theorem. All right, let me kind of start over. When you have a tangent and a radius, they are always perpendicular. So that means that this purple triangle right here is a right triangle. So we just found that BD was 14. All right, so I have 14 over here. We just found that BA was 48. So I have 48 right here. All right, so I'm just going to call this y for a second. So I need to find y. So that'll be the Pythagorean theorem. So I'm going to go y squared is equal to 14 squared plus 48 squared. All right, so that means y squared is equal to 196. And then let's see, 48 squared, correct. Okay, so y squared is equal to 2,500. But then I take the square root of both sides. And what's that? What is it? 50? Okay, so that's why AD is going to be 50. Does that make sense?